introductory video. I've tried to create this video multiple times by now. Hopefully this will be the last. I tried to accommodate multiple to multiple groups. However, I think it is gonna be like an intermediate. It is gonna be targeted for people who have intermediate knowledge about Blender, because going too much into details for the novice makes the video exceptionally long, which I dread. So in case you are a novice, please let me know and I might recreate this as a lengthy tutorial for beginners, explaining step by step whatever it is that I'm doing. But for this video, it will be more of an overview rather than just going into the nooks and cranny, something like that of it. Anyways, let's begin. So this is the game plan. We're gonna stream the data using a Python script. And if you do not know Python, please do not be worried. I'm gonna add all the documents, the Blender file itself. I'm gonna attach it to the YouTube somehow, to the video, and you guys can download it, play with it, or recreate it yourself, since I'm gonna attach all the textures and scripts that I've used so far. Also, it's just gonna be a simple script, and I'm gonna go over it just to explain what it does. It's really cool to understand Python, especially for work or for like creating Blender projects with Python. Now, before that, I wanna explain how we're gonna get the data, and then how we're gonna channel it to geometry nodes, and from geometry nodes we're gonna use the shader to basically make it pretty. All right. Now, this is not the script itself. I showed you the script. This just creates a CSV file of the data points. Now, the data comes from Python OpenSky, which is a library that you can like request the data of aircrafts that are in orbit currently, and it gives a lot of data other than these, which I'm gonna show in the CSV file. So once I call the data, this is the data I'm getting from the library, and it gives much more data if you so desire. It also gives remarks, it gives sensor data, special packages, estimated airport arrival and departure, but I'm not gonna need those for this tutorial. What I'm gonna need is the iCow24. I'm not sure if I'm spelling it correctly, but this is basically the ID of each aircraft, and no two aircrafts can have the same exact ID. I have the origin country, which is where the aircraft came from, and if you notice here, it is this is the name of the country, but this won't be very helpful for us. We need the latitude and the longitude of the country itself, so we can create an arc going from the origin of the aircraft all the way to the aircraft itself, like you saw in the introductory video. To do that, I'm gonna compare the origin country's name to a separate CSV file here, which has country, latitude, and longitude. So I'm gonna read the country over there, and then match it with these countries, and then whenever there is a hit, I'm gonna read those data points to use. Now back to the OpenSky CSV, we've got longitude and latitude of the aircraft, the geo altitude, which is the altitude from sea level, and the velocity or the speed of the aircraft in air. So let's go back to Blender. This is the Python script. BPY is to be able to access everything in Blender. It's very important. It's basically anything you do in Blender, you need this library to be able to control things in Blender. The CSV is just used to import the country CSV, which I've discussed just now. There is the request, which is used to request from the URL of OpenSky, random, just to generate random numbers, and then threading. Threading is quite important. Blender uses a single main thread where there is no concurrency, similar to how my brain works. Unfortunately, I do not know how to multitask, so this is quite a challenge as a tutorial to be able to write the code itself and explain it as I go along. But basically, if I gave my Blender instructions to carry out on the main thread, it's gonna seize like working, everything's gonna go static, and then you'll see like loading, and everything will freeze in place until the tasks given are completed. Only then will it unfreeze, and we do not want that, or at least we need to mitigate that as much as possible. So for the threading bit, I'm gonna create a hidden thread where I will fetch the data on that thread, and then once I get the data, I'm gonna push it to the main thread and then update the scene in the update the data with the geometry nodes. All right, so this is the CSV file of the countries. I'm gonna create a dictionary with the latitude and longitude. We've got the update interval. How often are we gonna call through the function, the fetch open sky data? This is 60 seconds. Now you might think that 60 seconds is a long time, but however fast a plane is comparatively to the size of the Earth, it's nothing in comparison. So all the planes will be going really slowly, like the speed of the plane. So 60 seconds is, I believe it's even too short. Maybe 2 minutes, 3 minutes should be alright. The Earth object name is like the stream points, is the mesh created by the script, and the percentage to keep 5. Now 5% is, so I'm gonna delete 95% of the data of the planes that I'm getting from the source, because OpenSky sends 10,000 planes, and although 10,000 points is not a lot, when I instance my plane collection, it's gonna be really render heavy. I do not want that, so I'm just gonna keep 5%. You guys can play with this, and depending on your GPU, you can settle on a number that works for you. Perhaps if you have a really strong GPU or a strong setup, all 100% will not be a problem. All right, this is the function to call through the data, and then once we get the data, we're gonna place it in the latest data, and then we're gonna update it with this function right here. Now, there are two things I want to speak about the data. So I'm gonna head back here to the CSV file. For each of the rows that we're getting, I'm gonna create a point, just a single point, and each of the data, like velocity, altitude, and so on, will be an attribute on that point, like a characteristic on that point. So this is what I'm doing right here, and I want you to take note of this right here. The iCow ID comes in as a string, which isn't very helpful because Blender does not use strings as ID. So I need to change it to an integer to be able to use it as an ID, and this is what I did right here. And then I scale it between 1 to 999 because I do not want. You can scale it much more, which is fine as well. And then based on the iCow ID, I delete the values. So if a plane is deleted this time on this iteration, on the next iteration it will be deleted as well. And if it's kept, it will be kept as well. So you won't just see like planes or points going in and out of existence. And also here I'm taking the name, as I mentioned earlier, of the country, and getting the longitude and latitude from the country's CSV file up above. And I'm naming, these are the attributes I'm naming. The original longitude and original latitude is the longitude and latitude of the country, of the origin country, and everything else is self-explanatory. And then I'm registering a update, so it will just create a loop, basically calling the function over and over again. So now that we have understood everything here, I'm gonna go to layout and begin. Now, having selected the stream points, I'm gonna make it visible. Obviously we can't see anything because everything is here in the middle. I'm gonna just open the spreadsheet data to see all the data. So all these data are on the stream points, it's just that we can't see anything, which is just points in the middle. I'm gonna go ahead and click on the middle point here, the middle shader, whatever it's called. I'm gonna go mesh the points, gonna add this, and now Here's the idea. The longitude and latitude are data points for a spherical object. We need to change it to Cartesian because Blender uses x, y, and z coordinates rather than longitude and latitude. Obviously, there is an equation for that, and this is the equation. I'm just gonna go front view and zoom in a bit so you guys can see it. So this is the equation. This is what we're gonna use to calculate all of that. To begin, I'm just gonna add attribute, named attribute. I'm gonna duplicate it. I'm gonna use longitude, latitude. Now these come in degrees, and Blender doesn't work with degrees. Actually, like most math doesn't work with degrees. We use radians, and to do that, I'm gonna just go 2 radians for each attribute. So I'm gonna copy this to the bottom, add this as well. So now we've got the longitude and latitude of the aircraft in radians, and then I'm gonna add more math. Now, based on the equation, we will need cosine, sine, and 2 of those as well. One set for each. I'm gonna connect the values, and I'm gonna add a math multiply. I'm gonna connect this to this. No, this to this, yeah. And then I'm gonna add this to, is it this? No. Yes. Alright. And I don't think there is any need for multiplying the last set. So x, y, z. This should be an x, by the way. I'm gonna get a combine x, y, z. I'm gonna add this or connect this to the x, this to the y, and this to the z, and this to the y. If you notice, there is like multiply by r. Now I'm gonna keep r as 1. I'm just gonna add a math. I do not know why I didn't copy this, but I'm just gonna add math multiply, and I'm gonna get a value node. So this would be my radius. I'm just gonna put 1, and I'm gonna connect it to each of the bottom sockets. Right here. Okay, let me give myself a bit of space. So this is basically the setup. Now I'm gonna get a set position. I'm gonna see what happens to the points basically after I connect the set position to the position. So it works, and it works quite well. If you take note, this looks like the USA, and if you listen closely, you could probably hear an eagle. But this is about it. Okay, so awesome. I'm gonna create a node out of this because I'm gonna use it for the countries later on using the origin latitude and longitude. I'm gonna connect these together, and then I want these to stay like out of the node setup. So I'm gonna select all of these and then go Ctrl G to create a group out of them. Okay, this way too messy. Okay, this looks good. Now regarding the radius, I want each point, obviously all those are now in the same like altitude kind of thing, but we already have the altitude position of each plane, so we're gonna make use of that. I'm gonna get the altitude. I do have here the actual size of the radius of the Earth, which we're gonna be using. It is, alright, here we go. I'm gonna get the value node. It is 6371123 or something similar. Now this is the radius of the Earth, and this is the altitude from the sea level. So if we add these as in get a math node, and then if I add these, this is basically the distance from the center of the Earth, and then I want to scale it down. I want to scale it down to be like a scale of radius of 1. So I'm gonna divide this with this, and then I'm gonna use this as my radius. I'm gonna delete this. So to make this more exaggerated, like exaggerate the altitude of each point, I can add a multiply here, and then I can multiply this, for example, by 10, which gives, if you could see the points moving as I drag this, this is the difference between the altitude of each point. So I'm gonna keep this as at 2, perhaps 3. I'm gonna just keep it at 2 for now. We can just edit it later on. And we're all sorted regarding the points of the plane. And I'm gonna just hide the Cartesian plane. I'm gonna hide the camera as well. It's bothersome. All right. Now, what do we need to do? We need to create a slurp. What's a slurp? It's basically connecting 2 points, positions, with a curve, like as you saw in the introductory video. Now I'm gonna explain how the slurp work in a demonstration rather than using this setup. I'm just gonna add here add mesh icosphere. I'm gonna add a new geometry nodes. Now what is the equation for a slurp? I've got right here. Ooh. So this is the equation of slurp. I'm just gonna drag this and scale it up so everyone can see the equation. So this is the equation for a slurp, where it seems complicated, but it really isn't. To create this, we need to start here. This is called omega. So I'm gonna start creating omega. Now the equation of omega is r cosine p dot q. P and q are the positions of each point that we're trying to connect. So what are we trying to connect? I'm gonna first isolate. I'm gonna go mesh 2 points so we can see the points here. Ooh, I've added this on the slurp itself. Okay. Mesh 2 points, not curve. Mesh 2 points. So these are the points. If these points don't appear in your Blender, please make sure that you are in cycles, because they do not appear in Eve. Mesh 2 points. I'm gonna isolate 2 points because I want to show you which 2 points I'm trying to connect with each other. To do that, I'm gonna get an index. So I want to keep the points where the index is equal to compare. I'm gonna get a compare node because I'm trying to compare values. I'm gonna change this to integer and change this to equal. So I want to keep nodes where this is equal to, let's say, index of 0, but rather than keep it this way, I'm gonna get an integer. I'm gonna keep this at 0, so equals to this integer. So I'm gonna keep the point that has this integer, which is here. I'm gonna select a new point as well, another point. So I'm gonna copy this, paste it, and then change the integer to like maybe an integer of 5, doesn't matter. And I want to add these two. Rather than add, I want to I want to add a Boolean math node. So I want to keep the point if the integer is equals to 0 or the integer equals to 5. And now I've got 2 points. Now I want to connect these 2 points using the slurp. To create a slurp, obviously we need a curve. So I'm gonna get the curve line. And I'm gonna get the join geometry so we can see the line. Now I want to move this point to create the slurp. I'm gonna follow the equation. So here we got r cosine p multiplied the q. Now how do we read the positions of these 2 points? Okay, we need to sample based on the index that we use to keep. So I'm gonna get a sample index, and what is it that I'm trying to read is the position. And position, I'm gonna get a position. Position is obviously a vector containing x, y, z. So I'm gonna change this to vector because this is the value I'm trying to read. And which integer, like what point, or what is the integer of the point I'm trying to read? I'm trying to read this integer right here, and I'm gonna the the geometry that I'm using obviously is of the point itself. So I'm gonna add this here from the mesh to points, and I'm gonna just Control Shift D to duplicate this, and I'm gonna attach the second integer to here. So now I've got the two indexes and I've got the two positions. Now these are positions P and Q respectively. The idea is to get a vector math node next, change it to a dot product. I'm gonna connect them with each other, and I'm gonna get a simple math node, change it to arc cosine, which should be here, and we're sorted. This is basically my omega equation. Now once we have the omega, we can move along to the actual equation. So the slurp is sine. I'm gonna just be getting the math nodes as I'm going through. 1 minus t. Now what is t? T is basically the factor. So if you imagine like this position of this point and position of this point, there is like distance between them. I want to move this curve here, but I need like a interval. Like I need to do calculations at intervals, and there is an really easy way to like check the intervals of the curve. It is given by the factor of the curve. So the factor goes from 0 to 1 here, and each like point in between is given a number, obviously between 0 and 1. So 0, 0 0.1, 2, 3, 4, 5, up to 1, no matter how long the curve is. And that will be my t right here. So I'm gonna get a spline parameter. So this is the factor. I'm gonna be using this heavily in the whole tutorial, so keep that in mind. I'm gonna take the factor as t, so it is, I'm gonna just create a math node right here, a subtract. The idea is 1 minus the factor, and then multiplied by, we need to multiply this multiplied by omega, which we recently calculated, and then sine of that. This should give me the first part excluding p, so I need to multiply by p, and multiplying with a vector needs a vector math node. I'm going to change this to multiply. I'm going to multiply this by the position p. Now I've got the top side of the equation excluding the over sine theta, but since these two have the same denominator, I'm just gonna leave it in the end. Now I'm gonna do this part right here, the second bit. It is sine t omega. So I've got a math node, I've got t, I've got omega multiplied by each other. I need the sine of those, and then I need a multiply of the sine of it multiplied by the value of q. And then I just need to divide these two values right here. Actually, I need to add these first, and then I need to divide these by omega. So this is by sine omega. So I'm gonna take another sine node, connect it right here, and this is it, right? This is actually like the end result. Hopefully, I'm gonna get obviously, if you look at the curve, this curve that we're trying to like set the position of or like change to accommodate these 2 points, it just has 2 points, and this won't work. We need more geometry. So I'm gonna get a resample curve. I'm gonna add it right here. I'm gonna change this to length, and then I'm gonna drag this all the way down, and then afterwards I'm gonna get a set position, because we're moving the curve based on the equation, and I'm just gonna drag this to the position. Hopefully, if everything went well, and everything didn't go well, there is a blunder somewhere. There's 2 points. Ooh. Yes, this is the issue. So I'm gonna go mesh 2 points, place the points right here, and then rather than this mesh. So I'm gonna go instance on points. Gonna instance a sphere, UV sphere, and then there is no need for it. Bear with me 1 second, I'll show you the end results. So mesh to points is, we've already taken care of that. And I'm gonna drag the mesh to points all the way to the sample index right here, and I'm gonna make this much smaller. This one right here. Now we're talking. All right. So hopefully you guys are not confused. We did the same thing. It's just we need to instance afterward and then put the selection just on the instance because the ID changes. So this should be it. Now I want to create a node out of the SLERP. So this is the equation for the SLERP. I'm gonna select these. I'm gonna keep the sample index outside because I don't really need it. I just need the inputs to be the positions, and I'm gonna keep the factor outside as well. I'm just gonna add this right here, to showcase that it's connected. I'm gonna highlight all of these, then go Control G to join them. Maybe fix it a bit. Honestly, I don't care too much. This is the equation if anyone needs to like follow up. And I'm gonna tab back out. I'm gonna create a save user for this. I'm gonna call it toSLERP. Okay. I'm gonna go Control S to save it. Now we've got the equation to create a SLERP, and the inputs are just the two positions and a factor in between them, like the factor of the curve itself. Now that we're done here, I'm gonna hide the icosphere, and I'm gonna hide the SLERP equation as well and get back our points. Awesome. Now that we have that, by the way, nothing is showing here because now they're points, so I'm gonna click on points right here just so we can see the attributes. Okay, we're back here, and we need to iterate over all the points. We need to iterate over the points, and then for each point, for each aircraft, we need to connect it to its origin country. To do an iteration over the points, we're gonna get for each element, and the for each element basically really works uniquely. It's unique in Blender if you haven't used it before, because there isn't anything in between, but it still works because the first geometry circumvents the whole thing, and it's only the second geometry that updates based on whatever you did right here. And what do we need to do right here? We need to get the toSLERP. Now we need to create a SLERP. Now we're iterating over, like we're going through the points, and the first vector is the position of the aircraft itself. So we just need a position right here, but we can connect it this way. It won't work for each element. I'm gonna connect it out of it, and then I'm gonna drag it all the way here. And the second position we need is the position of the home country or the origin country. Now these, if you remember, are attributes, named attributes, so to be added from the script. So I'm gonna go origin longitude. Okay, something is just a second. Okay, origin longitude and origin latitude. I'm gonna hook these inside. So for each point, I'm gonna read the origin longitude and latitude. And if you do remember, these are we need to change these to Cartesian coordinates. So I'm gonna name this to Cartesian. I'm gonna create a safe user for it, and then I'm gonna create a copy right here. I'm gonna drag the longitude. Oh, something is wrong. we do not want. What is the need for the geometry right here? Set position. Yeah, I do not like this. Okay. I do not like this. Okay, I'm gonna do something right here. I'm gonna copy everything. Control C. Hit tab to go back. I'm gonna just copy this right here. I'm sorry to. I'm gonna copy this. Here and here, and we're gonna make use of okay, I'm gonna undo. I didn't do it the best way I could. So I'm gonna get a set position. Set position. Basically, I don't want the geometry within, I want the geometry out. So I want the geometry to be out of it. I just want to give a, basically here, I want to output this. I do not need an output for the geometry. I just need to output the vector. And I do not need an input for geometry as well, just the vectors themselves. So, yes, no. I'm just gonna, okay, yes, it works. I just viewed it with the viewer node and it works. So we've got everything sorted basically right here, and it has updated accordingly right here. So I'm gonna drag the longitude back to the first socket, the longitude to the second socket, and for the third socket it's just an input of 1 because we just need, you know, we standardize it as a radius of 1. And then I'm gonna connect this to the second position. And finally, for the third position, we need a factor of a curve. To get a factor, we need a curve. So we're gonna get a curve line. I'm gonna connect this to the output socket, and I'm gonna get a spline parameter. Use the factor here. And finally, now I've got the vector. I need to set the line itself. So I need a set position, because for each point we created a curve, and then we're gonna set the curve from the position to the origin country. So if I drag this and place it right here, and assuming everything works correctly, okay, I need to update with the second socket. I should see a curve going from each point to the country. Obviously you see that the points themselves look jagged because there is no enough geometry on the curve itself, on the curve line. So I'm gonna add a resample curve, and then I'm gonna change this from length, from count to length, and then I can drag this all the way down. Now we've got smooth, a smooth slurp or a curve going from each country. This is the United States, from the center of the United States to each point. If you do use the updated version where you get like the departure airport and so on, you can use the departure airport as the position for each, which I think would make it look cooler. But since I've already used the country, I'm just gonna stick to it. Control S to save. I'm gonna drag this back. Now I want to instance on each of those, on each of those points. I want to just instance on the end of the spline. So you could imagine like this curve contains many points because we resampled the curve itself, but I don't want to instance on each point, just the last. So to do that, I'm gonna get a instance on points. I'm gonna drag here a paper plane that I've created, just a second, and misspelled, I think. This is the paper plane I've created. I'm just gonna drag it right here, change this to relative. I'm gonna instance this on the geometry. Obviously I haven't connected the socket here because there is a reason for it. I do not want to overwhelm my scene, so I'm gonna get a endpoint selection to make the selection that I just spoke about. I'm gonna add this selection right here. Only after that will I connect these. and it's way too big, so I'm gonna say 0.002, let's say. Too small? Yeah, it is too small. Let's go 0.008. Okay, this doesn't actually look bad. Obviously, I can't see the curve, so I'm gonna get a join geometry and reconnect the original curve back here. Okay, now since both the start size and the end size are 1, that means it is instancing on both the beginning and the end. I do not want it to instance at the middle right here. As you can see, there are multiple planes here, so I'm going to go and set the set size, the end size, to 0. So here we are, 0. Everything now works accordingly. But if you notice, it's not rotated correctly. So each plane isn't rotated correctly. To fix that rotation, we're gonna rotate it to the curve tangent. So this is the curve. We're gonna get the tangent, and I'm gonna rotate it to the tangent. So I'm gonna get a align rotation to vector. I'm gonna get the curve tangent. We've got that as a node in itself, and the tangent is vector. I'm gonna add it to the vector, and then I'm gonna connect this to rotation. Now this looks wrong, and I'm gonna explain why. If I go back to my paper plane that I've created, you can notice that the plane itself is parallel to the x-axis rather than the yellow or rather than the y or the z. So I need to make sure that once I've added the align rotation, I change it to x, and once I do that, the rotation should work correctly. Okay. Here I can go and flip the rotation of the plane itself, but rather than doing that, I'm just gonna flip these two. Basically, flip the curve, and I'm gonna change the endpoints from start size of 1 to end size of 1. Same thing, just flip them, and now I've got the paper plane facing the correct direction. But even though they're facing the correct direction, the plane itself looks wonky because it can revolve. Like, I need the bottom of the plane of the aircraft to face the center of the earth. Obviously, planes, as they're flying above earth, they're always facing like the bottom of the air. The plane is facing the surface of the earth, except if it's doing like gymnastics in the air, a fighter jet like Isho or whatever. But to do that, I'm gonna add more rotation to the initial rotation. So I'm gonna create, and I'm gonna add another align rotation to vector. I'm gonna check the paper plane, the original paper plane, and I want to align it on the Z direction. So here I'm gonna click Z, yes, and the pivot should be X, alright? And then the vector should be, I'm gonna get a vector map. I'm gonna add, so this position right here, which is the center of the earth, you could say, is 0, 0, 0, and then we've got the position of each point. So I'm gonna get a position, I'm gonna subtract 0 minus position, and this should be my vector. I can add a normalize right here, and I should be set. So now we've got the correct rotation for all planes. That's great. So I'm just gonna tidy up a bit because there are some things that I want to do as well. I'm not very good at tidying things up, unfortunately, and I do not want the video to be 2 hours long. So I'm a bit of a haste. What else do I want to do? Yeah, so I want to scale. I want to give a random scale for each. So I'm gonna get a random node and value, and what's the value here? 0.008. So I'm gonna copy this. I'm gonna add this as the maximum because I think they might be a bit too big and overlapping. So this is the maximum, and for the minimum, I'm gonna just add 0.00. Let's say 5. This looks good. Now, if I connect this, it should work great. But what's the issue here? Once a new iteration to the planes update, the size will vary. So you can see like the plane growing and shrinking in size as the, you know, as we're reading more and more values, which we do not want. If it's a certain size, I want it to carry forward between iterations. That's where the iCow ID comes from. So I'm gonna get an attribute. So I'm choosing the size randomly, but I'm using the iCow ID, not the 24, because the 24 is a string. The ID we created as a ID, as a driver for the random value. So you've seen a change, and if a like this size, this plane will maintain the size throughout, because it has the same iCow ID throughout. And that's all there is to it for the scale, I think. Yeah, if there is an issue, we'll fix it. Now, other than this, I want to drag I've got a collection. I'm gonna just control save here. I've got a collection of planes I've created. I'm gonna hide it because I don't really need to show it. I just need to drag it. Ooh. Okay, I just need to drag it into the. So I want to be able to either show my paper planes or actual like mesh planes, like high. But this is a collection because it has multiple planes. I'm gonna add the planes in the description as well, so don't need to worry. I'm gonna click on separate children because we need to just select one. If I show this, you can see like there are multiple planes in this here. So I'm just gonna hide this. I'm gonna separate the children, relative, and if I add this here, it would work in as the instance. And I need to pick instance to pick just a single plane. Now here's what we need to do as well. If now everything works according to what we want, but there is an issue where if I need a driver for this, because if I select like on this point, I'm instancing this plane. The next time I call through the data, same with the scale, I need to be able to select the same plane that I selected the first time. So I'm gonna get the iCow name attribute. Actually, I'm just gonna drag it. I'm gonna drag the attribute to the instance index. So now it will always select the same plane because it's the iCow ID is what's driving the instance index. And great. So now that we're here, here's what I'm gonna do, because I want to be able to easily choose between either the collection of the planes, of the realistic planes, or my paper planes. So I'm gonna create a switch node right here. And what am I doing? So I'm gonna get my group input, which is literally right here. So I'm gonna select this, and if I open my modifier, there is nothing here yet, but I'm gonna use this as my switch. And what is the switch? So I can select the switch here. I'm gonna go to the group. Wait, I want to name the switch instance collection. So this is the name of the switch. So I want to keep it as false. Yeah, it is false. And if it is false, then I will instance my paper plane. Otherwise, I'll instance this. If I connect this back here on the instance, or everything went because there's still like the pick instance. I need to take it off if I actually pick the paper plane. So I'm just gonna get the same boolean and place it right here. So now I can click to bring back my realistic planes or the instance planes. I'm gonna make use of this in the material as well, because when they're paper planes, I want to color them. Otherwise, if they're not the paper planes, they're the actual collection, I want to use the initial, like the original material of the object itself. So we're gonna do this once we create the material right here. I'm just gonna do Control S for now. And all right, what's next? Before we begin creating material for these paper planes, I want to give this bit of these curves that we've created some geometry, because right now they're just curves and they won't appear in the render. I'm gonna go curve to mesh, and I'm gonna select a curve circle as the profile, but the resolution is way too high. 32 at 32, like I just need to bring it all the way down to 3, because you won't be able to tell the difference. It's so like slim. I'm gonna use this as the profile curve, and it is way too large at a radius of 1, so I'm gonna go 0.00, let's say 2. Still way too large. I'm just gonna divide this by 10 by adding another 0. Maybe it's 210. I'm just gonna bump it a bit to 3. This looks good. The curve itself, or the profile, is equally thick throughout, which I do not want. I want it to be thin in the origin of the country and thicker at the plane itself. So I'm gonna get a set curve radius. I'm gonna get also a, so I need to scale it based on the curve factor, the spline parameter. So if I mute this, like if you remember, there is spline parameter that we've used earlier, and I said we're gonna use a lot. So I'm gonna, based on the factor itself, I'm gonna add it to radius. I'm gonna unmute here. So now it is 0 here and 1 here, but I do not want it to be 0 here, because I do not want it to disappear completely. I still want a bit of thickness. So I'm gonna up a map range, and I'm gonna bump this from 0 to 1 to 0.1 to 1. If you see, once I added this, there is a bit of tiny geometry right here, and this is all I want right here. I'm gonna go control save. Oh, one more thing before we change it to mesh. So between the set curve radius and curve mesh, I want to save this curve parameter, because if you remember the introductory video, there was like, these lines are basically dashed lines, and to create this dashed line, I'm gonna need this parameter. So I'm gonna get a store named attribute right here, and I'm gonna use this as the value, and then I'm gonna call this spline params. You can name it whatever you want, and all good for the curve itself. Now let's set the material. I'm actually gonna set the same material for these two, but I'm not gonna set it right here, because if it's a collection, I want to be able to basically like do something with it. Hey, sorry about the interruption. Blender crashed. Alright, I'm gonna continue by adding a material, and I'm gonna go ahead and create a material. Actually, not a material. I'm gonna set material. Right. I'm gonna add new material. I'm gonna plane the material, plane, and splines. Alright, I'm gonna select the plane and splines right here, and then I'm gonna head to the shader editor, and we're gonna create the material for the curves. So I'm gonna first add an attribute, the same name I gave in the geometry nodes for the stored name attribute of the spline. I'm gonna use that as the coordinate system. So we can see from 0.1 to 1. I want to use that to drive a wave texture. So I'm gonna get a wave. It's a wavelength. Wave. If I can write wave texture. All right. So I'm gonna drive a wave texture. As you can see, I've got like a gradient where it goes 0 to 1, 0 to 1, actually 0 to 1, but sinusoidal, whatever. I want a harsher cutoff. I do not want a gradient. So to create the dashed lines, that is, I'm gonna get a color ramp, and I'm gonna set it to constant, and I'm gonna drag the white bit all the way down to the back. I'm gonna choose rings, and I'm gonna change the scale to 10. Yeah, I think this looks good. So now that we have this, I want to drive the color. So I want to create a color for each of the different what's it called, splines. Basically we already have an ID, so we're gonna use that. So I'm gonna get a iCow underscore ID. I'm gonna view that, and the reason they're all white is because this goes from 0 to 9, from 1 to 999. I want to map range it to go from 0 to 1, so I'm gonna add a map range, and I'm gonna add 1 to 999, and then keep it from 0 to 1. So now I've got a good gradient. I'm gonna then add a color ramp and use this to drive the color. I'm gonna select, rather than black, I'm gonna select maybe this green right here, and for the other end I'm gonna select just the color just behind it, like perhaps yellow, and then I'm gonna use rather than linear, I'll go HSV, and then I'm gonna choose clockwise, so all the colors of the color will appear. Now if you guys want different colors, you can choose different colors, it doesn't matter. Oh, for the initial wave texture, I'm gonna use this as a driver for the alpha channel, so that all the black areas become transparent. If I view the principal BSDF, I could see that the black areas became transparent, and then I'm gonna use this as both the color and the emission value or emission color. I'm gonna set the emission to like something like 3. Alright, this looks good to me. Now, what else do we need? I want the dash lines to appear to be moving backwards. To do that, but not just backwards, I want it to move according to the velocity of the aircraft itself. So I'm gonna get another attribute which we already have from the beginning, called velocity. And alright, how do we do this? I'm gonna get a mapping node, I'm gonna place it right here, and if I change the Z value of the location, you can see the dash line slowly moving backwards. So that's what we're gonna do. Location, I'm gonna add a combine XYZ so we can access the Z value, and I'm gonna get a value node. In the value node, I'm gonna add a hashtag frame. This will help. This will be a driver to drive the Z value, but this is way too much. If I click play, it just like skips over. So rather than and we left out the velocity. So I'm gonna add these. I'm gonna get a map node. I'm gonna add multiply actually this with this, but I don't want this to be this big. I want to like really reduce it. I can add obviously the scale it down here, or scale it out, scale it down. So what's going on right here? I'm gonna divide this by say 100,000, and if I click play, you can see that the dash lines move, but they move at different speeds based on the velocity of each of the aircrafts. Now that we have this, we need to take care of the aircrafts themselves. Now, if the instance is an object, which is the paper plane, I want it to have the same color as the light, as the curve, and if not, I want it to have the color, the initial color of the mesh, because in the collection, the planes already have their own colors. So there's something I need to clarify. I'm gonna go back to geometry nodes. You could tell that this is basically still the same object. Meanwhile, these are instances. So I need to accommodate for that. First, even if I add this material here, they will all have the same color, or actually not appear at all apparently. But that's because this is geometry. We need not this. Spline parameter. Yes, this is geometry. We need one for instancer as well. So I'm gonna add instancer right here. I'm gonna get a math node, add, I'm gonna add these two together. Okay, I'm gonna multiply the alpha here as well, multiply by this probably, okay, by this, and everything disappears. That's interesting. Right, make it an add and add the instancer iCow ID. So now we have it as we want it. Now if I change this, I'm gonna show you what I mean. If I change this to collection, all the planes are gonna have the color, which I don't want. So I want a way to eliminate that. Luckily we already have a boolean. So this tells me when I'm instancing a collection if it's true, and I want to, if I place it here it won't work because I want the opposite of this. I want to change this yes to a no, so that if it is an instance collection it doesn't use the material, otherwise it does use the material. So I'm gonna get a math node, actually not a math node, a boolean math node, and select not. I'm gonna take this boolean not more not, and then place it here. Nothing changes if it says a paper plane, but if I turn on the instance collection, the original color of the planes themselves appear. I'm gonna turn it off, and I'm happy with the results as they are. I think I'm all sorted regarding the materials and the paper planes. You guys can play with the color of the paper planes if you choose to. I'm gonna go ahead and move to creating the earth. I'm gonna create the realistic earth because the globe of the on the table at the end of the video isn't really anything special. Alright, I'm gonna hide this, and then I'm gonna add my earth. I'm gonna add a mesh, a UV sphere. I'm gonna add some subdivision surface. I'm gonna control S to save, and I'm gonna add one subdivision to the viewport and two to the render. I'm gonna keep it as is. What do I need to do? Oh yeah, so I need some other things as well. I'm gonna change the name of sphere to earth, and I'm gonna add a empty plane axis, scale it. I'm gonna name this earth objects, and it's important you name it earth objects as well. I'm gonna tell you in a second why for in a minute. And I'm gonna select earth and the earth object last, and then I'm gonna parent them to object. So I've got my earth object controlling the location of my earth. I'm gonna also add a sun, and I do not need to move the sun right now. Actually, I'm just gonna move it and then rotate it this way. Right? So what do I want to do before placing material on? Actually, let me show you guys the materials so you understand what I'm trying to achieve. I'm gonna open this. So yeah, I'm gonna open the texture just to show you what I have ready. I've got the material of the earth during the day. I've got the material of earth during the night, a cloud texture, and some like displacement or not displacement. It is used to drive the displacement or the bump node, but this is the height, like the elevation of the earth. So you've got like a mountain range right here, perhaps some mountains as well right here, and the black is sea level, and everything white is, like the whiter it is, the higher it is. So we're gonna use that as either displacement or displacement and bump. But and this is a globe. I'm gonna add this, but I'm not gonna show how I did it because it's quite easy. So let's start here. I want to mix between this and this depending on where the sun is. So if the sun is hitting this normal right here, this side, I want to color this day, and if it's the back side, I want to color it night. So I'm gonna click on my earth object. I'm gonna add, I need a mask for that. I'm gonna add a geometry node editor right on it. Here it is, and I'm gonna drag my sun object into the scene. Then I'm gonna get a position to get the position of the points on the sphere, and I'm gonna get a vector math node set to subtract. I'm gonna click on relative here, and then I'm gonna subtract the position from the location. I'm gonna normalize this, so set normalize, and finally I'm gonna get the normal of the sphere for comparison, and I'm gonna get the dot product between these two. So dot product between these two. I'm gonna click on the group input and select the viewer just to see my mask, and as you guys see, I've got the colors, well, black where it is not and white where it is. You can flip it, but you can use whichever you want. So I can flip these. I'm gonna use it as is. I'm gonna call this, actually there is no need for a node. I'm just gonna add a store named attribute, add this to the value, and then here I'm gonna click it. I'm gonna add dark area. That's what I'm gonna name the mask. I'm gonna go to shader editor, add a new material. I'm gonna call the material earth. Okay, I'm gonna get the attribute dark area, what we just created. I wanna view it first to make sure that, yeah, it is what we need. So I'm gonna close this. I'm gonna click on the principal BSDF. I'm using node wrangler. I'm gonna click on Control T here to get some object coordinates. I'm gonna make sure it's UV selected. Actually, it's UV selected, and I'm gonna add the texture coordinates of my day color. Actually, this is topology. I do not want this. Of where is it? Base color day. Give it a second. Alright, I'm gonna shade smooth the sphere. Yeah, looks good. I'm gonna mix it now with the night color. I'm gonna get the night color. I'm gonna Control Shift D to duplicate this, and I'm gonna add the night texture. As you can see it, I'm gonna just show it to you guys without anything, and I'm gonna use this mask that we created as a driver between the colors. So I'm gonna get a mix color, place it right here. I'm gonna use the color as the factor, place this on the top socket and this on the bottom socket. Just gonna rearrange these a bit and place this as the color. So I want to make sure that we've got everything. So here's the sun object, and to see this, yeah, it's working, but I want to enhance the, basically bring it in. I'm gonna add a color ramp right here. I'm gonna slide the white in and the black perhaps a bit to end as well. Right, I prefer this kind of gradient. I'm gonna place it on the factor, and I'm gonna use this as the driver. This looks all good. Now I want these like night lights of the city to light up, so I want to use this as a mask. Actually, I need multiple masks for the what's it called? Yeah, for the lighting. But before that, I'm gonna add emission and sensor. I need to emit color out of these areas. What I'm gonna do is I'm gonna use this as the emission strength. Yeah, and then I'm gonna use this as the emission color. So I can multiply this by like 5 to make it brighter, but now it becomes way too bright. So I still want to add another color ramp right at this color ramp. Sorry, on the night texture on the color, just so I can like decide how which points will allow it to give color. If I bring it in, you see like less points are selected. I'm just gonna leave it as is, or just a tiny bit in. This will be my color coordinates, and I can multiply this by maybe 10. Yeah, looks good. Right, since it's a color that we need here, that we added the color ramp, rather than white, I'm gonna select a nice orangey yellow. Yes, looks nice. Alright, I need more emission, but this kind of emission is from layer weight. So I'm gonna get a layer weight, because if you look at Earth from a satellite or images, you can see kind of like a halo around Earth, where like the horizon, like the sun hits the horizon. So I'm just gonna show you a Fresnel, and you can see this like halo, but I want it more exaggerated. So I'm gonna get a color ramp, then add it here, and I'm gonna drive the black values in. This looks good to me. Alright, I want this as the emission strength, both in emission strength and color. So initially I've got this as my initial strength, and now I'm gonna add to this, this Fresnel factor. So I've got this halo, and as for the color right here, this is for strength. I can add a multiply node after the Fresnel to make it more pronounced, but for now, I'm gonna get this right here. I want to change the color as well, because this is basically for the city lights. Meanwhile, the halo, I want it to be like a very light blue. So I'm gonna add a new mix color, add it here. So I want this to be like the data from here to be yellow, and I want the halo to be blue. So I'm gonna select blue, and obviously I need a factor, and this will work well as the factor, so you guys can see exactly what I mean by this. I hope my explanation, I hope you guys understood what I'm trying to say. Alright, I'm gonna use this as my color, and we can now view the principal BSDF. Yeah, looks good. Great. Alright, I'm now gonna get I'm gonna increase the sheen to 0.75, and I'm gonna make the tint a very like bluish color. It can go dark blue, but I'm just gonna go eye it out. This doesn't look too bad. Yeah, it doesn't look too bad. Alright, I'm gonna take the roughness all the way to 1, and honestly I'm happy with the results. Perhaps, yeah, I think once we make the scene darker, it would pop out more. Perhaps I can multiply a bit, I can add a bit of, nah, I think it's good as it was. Alright, I'm gonna leave it as is. What do we need to do? Alright, I'm gonna create the environment, but before that, should I create the environment or the clouds first? I'm just gonna create the clouds. Alright, I'm gonna add a mesh UV sphere. Ooh, actually I'm gonna hide the UV sphere, and there's something I forgot to do here, which is quite important, and I'm gonna first Control Shift D to duplicate the color texture. I'm gonna change it to the depth map that we spoke about, and it's non-color. Make sure that it's non-color, and I'm gonna use that as a bump node. So I'm gonna get a bump node and add this to height. I'm gonna reduce the strength. I'm gonna actually show you guys what it does before reducing the strength. I'm gonna use this to the normal. You can see it's quite exaggerated. I'm gonna change the strength to 0.1, and you guys can play with the distance however you see fit. Now I could use this to run a displacement, but honestly it's not required. I think it just gives extra, like, it needs more calculations for no apparent reason. It won't make much of a difference. Well, you guys can do that, but do enable it in the material. Now that I'm done with this, I'm gonna hide the earth, go back to the sphere that I created for the clouds. I'm gonna add add modifier subdivision servers. I'm gonna take it all the way to 3, and that's quite important. So I'm gonna create a new material, and I'm gonna call the material clouds SS. Apparently that's how clouds is written. And we do not need principal PSDF. I'm gonna add a principal volume. So what's the game plan? I want to create a volume, like, you know, a shell, kind of hollow in the inside, and like a thin volumetric shell. To do that, I'm gonna take the details, the density to 0, and we need basically to create, we need a coordinate system. So I'm gonna go Control T. I'm gonna remove the image texture image for now, and I wanna just view this. I'm gonna select object coordinates, quite important, and object coordinates, quite important. Yeah, looks good. And then I'm gonna get a vector math node, a length, and this basically tells me like the distance. All right, and I want to create like a comparison where, like, okay, I want to delete the distance that is less than a radius that is less than so on, and I want to keep what is greater than so on. So like a comparison kind of thing to create like a slice. So I'm gonna take the length, and I'm gonna get a math node set to compare. Compare. I'm gonna hook it right in. I'm gonna take this all the way close to like 0.995. Sure, let's see. And I'm gonna place this in the actually we can see it in the volume. We can't see it in the volume. I'm gonna set this in the emission strength. Okay, I'm gonna go to the world and I'm gonna first delete all of this. I'm gonna turn the color of the world all the way to 0 and make sure that I'm in render mode. So yeah, and we did, oh my days, did we view Earth without render mode? It's quite insane on my end. Hopefully it still looks nice. Honestly, yeah, a bit too dark, but we're gonna fix that in a second. That's fine. So I'm gonna hide Earth, and bring back my volume. So object, I'm gonna play with the epsilon value, like reduce it to perhaps this much. This looks good, like a hollowed egg. Now I'm gonna get a texture, image texture. I'm gonna get my clouds. I'm gonna hook the object coordinate here. I'm just gonna view the clouds. As you guys see, this is on the surface, I know, but it looks awful because it's linearly projecting, actually flat projecting. I'm gonna change flat to sphere and it should work accordingly. So this looks good. I'm gonna then take the compare. From the compare, I'm gonna get a math node, a multiplication, and I'm gonna multiply these together to get like a complete mask. And I'm gonna place this in my emission strength. I'm gonna delete the surface, just keep the volume and something. Okay, perhaps I should add the nice, add a math multiplication, set it to 300. Ooh, 200. Something's not right, something's not correct. Ooh, this is not add, this is multiply. Okay, so we've got our volume. I think it looks nice. I'm gonna get the earth back, and then I'm gonna scale the volume just a tiny bit, just so it over, like it's out of the earth. Place it as a skin, kind of. I like it. I'm gonna increase the strength of my maybe 220 of my cloud. Make sure density is set to 0, and this doesn't matter. Just the emission color and emission strength. So once we're done here, what do I need to do? I'm thinking, is this too light? Is this too dark? Alright, we can fix this. We can fix this. Okay, first of all, I'm gonna select my sun and change the strength all the way to 10. Like all the way to 10. This will really make this pop off. And I'm gonna change the color to a bit of a yellowish color. I know that it's the atmosphere that creates this yellowish effect from the sun, and it's not the real color of the sun, but I don't care, it looks good. So maybe a bit of a yellowish color. What do we need to do? Is it shaded smooth? I'm gonna make sure that it's shaded smooth. Okay, let's create the environment. I'm gonna go to world. Is it set to? Yeah, okay. So I'm gonna add a control tier, remove the environment texture. I'm gonna use the generated, doesn't matter with the mapping. I'm gonna get a Voronoi texture. So I'm trying to create clouds. I'm gonna show you what this looks like. So this is the distance and this is the color. This is way too big, as you can see, and it's funny, I try to lift my head like I want to look up. I'm gonna get a color ramp, yeah, I'm gonna set the scale all the way to like 250, not 2500, 250, and you can see that it's like a static, but if I drag this in, yes, looks much more like a. Ooh, I'm gonna set the background here. I'm gonna set this as the color. Okay, now I can play with the strength. I can set the strength to like 2, and you can always like drag this in. If it's still like too apparent, you can increase this to like 300. And make sure that you like reduce the randomness, because the randomness creates more stars. Not really, but anyway, here. So I'm gonna remove the overlays just to make sure I can see what's going on. Maybe increase randomness a bit. It looks okay. I'm gonna increase bump the strength to like 4. They still look too big for me. I'm gonna change the scale to like 500. Yes, now we're speaking. Yes, not bad, not bad. Okay, I'm gonna push this in. Okay, I'm gonna click Control Save to save everything. And what else? Yes, this is a bit okay. There are multiple ways to do this, but this is a bit too dark. I still want like a color or an environment to like light up my scene, but just a tiny bit. So what I'm gonna do, I'm gonna get a mix shader. I'm gonna mix between this shader and another based on the is camera ray. So if it is the camera ray, I want to look at the stars, as you can see. If it is not, I want a bit of a color, but this 4 is way too strong. Just a bit. Yeah, just a bit. Doesn't look bad, does it? I'm gonna go, perhaps this is too strong. Actually, I'm gonna just reduce the color. Okay. I'm gonna, for the earth object, I'm gonna select the earth object. And I want to, basically for the emission, should I just bump the color of this a bit? I'm gonna check it out and see what happens. Ooh, no. Try drag. Yeah, but this, I don't want to color the whole not sure, perhaps it's a color thing. Like I can multiply this. I think this is alright. We can play with the spread of the light, like the angle. Just a bit. Alright, moving on. I don't want to dwell on this too much, but already took so much time. You can always play with it to like make it a bit better. I think this is quite alright. I want to set the sun, so I'm gonna bring back my overlays. I'm gonna click on my sun. So we've got in the earth objects, we only have earth, unfortunately. I'm gonna add the sphere, which is called, let's name it volume or clouds or whatever, and the stream points, so volume and stream points to the earth objects. I'm gonna control P, same thing we did to earth. So now get my stream objects. And this and this, control P objects. Awesome. So now my empty like controls all three like stream object, which is the plane, which is currently I'm gonna, can I see it here? I can still see it. So if you can't see it, you can scale it like a bit, and the earth and the clouds are all like jumbled together onto earth object. Why did I do this? Because I created a script right here. I'm gonna go to scripting, not sculpting. I'm still trying to find my shading and animation. Scripting, nice. I created a, I'm gonna show you guys. So this is the empty. I created a script which like uses lunar year, like Julian days and so on and so forth, to calculate the position of the sun based on the earth object, based on this. Actually, you need to name it exactly this. So I'm gonna copy this, go to my earth objects and rename it like this. And the other thing you need to have is a sun object, or like a light source named sun. So you can name this sun, you have to name this sun, and this is sun as well. So what it does is, relative to earth as a center, it's gonna calculate the position of earth right now, like as it fetches the same data. So I'm gonna click on this and you guys see what's gonna happen. It also like tilts the earth, because the earth is not completely leveled, it's tilted on its axis. So I'm gonna click play and you see like there is a tilt. You can see the tilt is about 24 degrees, and you can see that the earth is placed 100 like distance apart, and then it's projecting here. And because we already, I'm gonna go back to layout, because we already created the mask for the sun, it will always be hitting the right direction. Like you can see, this is my earth and this side is, yeah, okay, maybe the spread is too big on the sun. What is my sun? I'm gonna reduce the angle. Yes, this looks correct to me. So perhaps I'm gonna go to my world view and reduce this to like, it's a bit too strong. Yeah. Looks good. Alright. I click on my earth and object. You know what I think this volume is way too small to, like, I'm gonna bump it to 350 and I'm gonna scale it down a bit, just a bit. Yes, I think this is good. I think you guys can play with it to create like maybe a more attune it basically to your liking, but this is about what you need to do. So it's just about like playing with the values, I suppose. The more values you play with, the better it looks. If I keep this yeah, this looks shit. Yo, what the hell? I'm gonna hide the volume for a second. Okay, it is the volume that's giving me the awful color. Okay. Gonna bring back the volume. Okay, I think I quite forgot that I'm creating a tutorial. Alright, I think I'm gonna leave it as is. All you guys have to do, go to scripting and press play, and you should have like an update whenever whatever intervals you set on, it will update, and you guys can look at the planes. The only issue here is you can't tell the planes apart really. Like I can't tell what is the name of this plane, where is it coming from at a glance. In version 5.0 that's coming soon to Blender, they stated that they're gonna do more things with strings. So hopefully, I was thinking to create like a banner, like coming out from the end of the plane, where like details are written on the banner. So that might be nice, maybe something you can create. But to me this looks okay as a project, and hope you guys enjoyed it. And if anything, any questions you guys have, just let me know in the comments. I still don't like this shaded area, but I took so long to create this tutorial, and I can't see myself going into the nooks of it honestly. So goodbye.